Okay, welcome to a new deep dive. Today, we're tackling something pretty crucial and complex.
Hmm.
How cutting-edge technology, specifically machine learning, is being deployed, well, right on the front lines of fighting financial crime.
It's a really high stakes area, isn't it?
Mm-hmm.
Financial crime, I mean, it doesn't stand still.
Mm.
And the amount of data involved is just, it's immense.
Yeah.
Traditional methods, they just can't keep pace anymore, not with the sophistication and the sheer volume.
Absolutely. And our guide for this exploration today is an insightful article from FinCrime Intelligence. It really digs into this intersection.
Mm.
Our goal, well, it's to cut through the noise, pull out the really important insights, and give you a clear picture, kind of a shortcut, actually, to understanding exactly how ML is making a difference here.
Think of it as getting the distilled essence, how this advanced tech is helping institutions grapple with crime that's just getting more and more complex.
So let's jump right in. When we talk about machine learning in this specific context,
Oh,
what are we actually talking about? What does the source say it is?
okay, so at its heart, machine learning, ML, it's a branch of AI, artificial intelligence.
Hmm.
The core idea is systems that can, well, learn from data, from experience,
Right.
which is different from older systems where you had to explicitly program every single rule, every scenario.
Okay, so instead of me coding if this and this happens, flag it, you're sort of showing the system examples and letting it figure out the patterns that should lead to a flag.
Exactly that. In the financial crime world, that means using ML to analyze these absolutely massive data sets, spot complex patterns hidden in there, and even make predictions about potential future risks.
Yeah.
The source really emphasizes its power in areas like, say, fraud detection, risk assessment, customer profiling. And that's because it has this amazing ability to adapt to new threats and pick out anomalies, things that rigid rule sets would just completely miss.
Okay, but how does it actually do that learning? I mean, it's not magic, right?
No, definitely not magic, although sometimes the results can feel a bit like it. It learns by processing historical data, looking for those patterns, correlations, outliers,
Mm.
but without needing those fixed pre-programmed rules.
So it learns what suspicious looks like from the past.
Kind of, yeah. It's like teaching the system to recognize suspiciousness based on past examples you feed it.
And the article breaks down different ways it learns, different types.
Yes, it highlights the main approaches. First, there's supervised learning. That's where you train the model using labeled data,
Labeled data, meaning,
meaning you feed it examples of transactions or customer behaviors that you already know are fraudulent or linked to money laundering, things you've tagged as bad.
got it. So you're saying this is bad, learn what this looks like.
Precisely. The model learns the characteristics of those known bad cases so it can predict similar ones in the future.
Okay.
Then you've got unsupervised learning. Now, this is fascinating because here the algorithms look for hidden patterns or unusual data points without any predefined labels.
Ah, so you're not telling it what's bad beforehand.
Exactly. It's
Yeah.
incredibly valuable for finding completely new types of suspicious activity, maybe risks you didn't even know existed
Mhm.
or, didn't know how to label yet.
Wow, that's powerful. Finding the unknown unknowns, basically.
Right. The source also mentions semi-supervised learning, kind of a mix of the two, and reinforcement learning, which is more about learning through trial and error.
Hmm.
But supervised and unsupervised, those are really foundational for a lot of the intelligence systems we see today.
All right, let's shift gears then. From the theory to, well, the practical side. Where are we actually seeing ML used right now in this fight against financial crime? What are the real-world applications the article mentions?
Okay, yeah, this is where you really see the impact. Transaction monitoring is a huge one. ML just excels at sifting through the immense, just unbelievable volume of transactions
Mm.
to highlight the truly unusual or suspicious ones. It goes way beyond what a human or even a static rule-based system could possibly manage.
Right, because trying to look at every single transaction manually is just, it's impossible now.
Completely impossible, yeah. It's also making big waves in fraud detection. Criminal tactics, they change all the time, right?
Constantly.
And ML models can spot these new patterns and behaviors, things like subtle shifts in how a user normally interacts or spends their money, things that indicate emerging fraud schemes.
So it's adapting almost as fast as the criminals are, ideally. What about figuring out customer risk?
That's customer risk scoring.
Mm.
ML allows for like a continuous assessment of risk. It dynamically updates based on ongoing activity, maybe where transactions are going, who they're connected to. It moves beyond just that static score you get at the beginning.
More dynamic.
Yeah. And then there's sanction screening. The article points out a big benefit here. ML is significantly reducing that massive headache of false positives.
That might be the same name but isn't the problem.
Exactly. Those alerts where a name looks similar to someone on a sanctions list, but it's not actually them. ML learns from past alerts to get much better at filtering those out.
That reduction in false alarms must save compliance teams just a ton of time.
Oh, a massive amount of time and effort. It also enhances the initial stages, like KYC, CDD, know your customer, customer due diligence.
Right, the onboarding part.
Yeah. ML can analyze all sorts of data points during onboarding documents, someone's digital footprint, public data, to build a much richer, more accurate picture of who the customer really is and what their risk might be.
Okay.
And there's a specific, pretty tricky problem that helps with too. Synthetic identity detection.
Synthetic identities. You mean totally fake people?
Exactly. Criminals creating identities from scratch using bits of real and fake information. ML can help identify these by spotting really subtle inconsistencies across different data sources, things a human might easily miss.
Well, putting it all together, ML is basically automating, optimizing, and just generally improving how effective and efficient these key compliance tasks are.
Precisely. And that efficiency, that effectiveness, it leads directly into these strategic benefits. Which brings us to, well, why is ML so valuable for institutions trying to deal with financial crime?
Yeah, the source highlights some really powerful advantages. First up, increased accuracy seems key.
Definitely. Because the models learn and improve over time, they get better at telling the difference between real threats, true positives, and harmless activities, the false positives.
So less chasing ghosts, more focus on actual crime.
Exactly. Less wasted effort. And that improvement over time is crucial. They aren't static. Then there's scalability. This is just fundamental.
Handling the sheer volume.
Right. ML systems can process these staggering volumes of data at speeds no human team could ever hope to match.
Yeah.
Which is essential in today's, global high-volume financial world.
Especially with data volumes just constantly exploding. And you mentioned crime evolves, so the tech needs to keep up.
Exactly. That's the adaptive detection benefit. ML models can recognize and respond to new threats, novel criminal techniques, much faster than you could ever update traditional fixed rule sets.
Makes sense.
It also offers improved investigation support. It can intelligently prioritize alerts, sort cases, basically presenting the most likely high-risk scenarios to the human analysts first.
Meaning the analysts spend their valuable time on the stuff that actually matters most.
Precisely.
Mm-hmm.
Which leads directly to resource optimization. Compliance teams, they could be freed up from the really repetitive, mundane tasks to focus their skills, their expertise on the complex investigations, the strategic analysis. The source really makes a strong case that these benefits aren't just nice to have anymore. They're becoming indispensable as regulations get tighter and threats get more dynamic.
Okay. It paints a very optimistic picture in many ways. But the article is also clear that it's not all smooth sailing. There are significant challenges, right? What are the main hurdles institutions face when they try to use ML?
You're absolutely right. There are considerable complexities. A major one is model explainability. Lots of these advanced ML systems are often called black boxes.
Black boxes?
Yeah, meaning it can be genuinely difficult, sometimes almost impossible, to clearly explain why the system flagged a specific transaction or made a particular risk judgment.
And that's a huge problem if you need to justify that decision, maybe to a regulator or even in court.
A massive problem, yes. Which ties directly into the next big challenge. Regulatory expectations. Regulators are, quite rightly, looking much more closely at how ML is being used. They're demanding transparency, auditability, strong governance frameworks. They want to understand the logic, even if it's complex.
They need to trust it's working fairly and correctly.
Exactly. And what about the data itself? The stuff that trains these systems?
Ah, yes, data quality. That's absolutely foundational, isn't it?
Completely. If the data you use to train the model is inaccurate, incomplete, biased, or just plain wrong, well, the model will learn those flaws. It'll make poor or misleading decisions.
Garbage in, garbage out.
Basically, yes. And this leads straight into a really critical challenge: bias and fairness.
How so?
Well, if the historical data used for training contains biases, maybe reflecting past discriminatory lending practices, or systemic inequalities, or even just skewed sampling, the ML model can unintentionally learn, and then perpetuate those biases, that could lead to unfair outcomes, maybe discriminatory profiling against certain groups.
Wow, okay. That's a really critical point. The tech isn't inherently biased, but it can unfortunately bake in the biases from the data it's fed.
It is a major concern, yeah.
Yeah.
And finally, there's the practical sort of nuts and bolts hurdle of integration complexity.
Getting it to work with everything else.
Exactly, getting these powerful new ML solutions to connect and work smoothly within an institution's existing IT infrastructure, which is often based on older legacy systems. That can be a really significant technical and operational challenge.
Lots to manage there.
Definitely. The source suggests that overcoming these requires really careful validation of the models, ensuring humans stay in the loop for oversight, and building strong governance structures around it all.
So looking ahead then, what does the future hold? What's next for ML in this space? What kind of trends does the article point to?
Well, the trends suggest a move towards directly addressing some of these challenges while also pushing the capabilities even further. A big one is explainable AI, often called XAI.
Making the black box less black.
Exactly. Given the explainability issue and the regulatory demands, there's a huge focus on developing techniques to make ML models more transparent, more interpretable, so you can actually understand or at least get a better sense of why a decision was made.
That seems essential.
It really is. Another really interesting trend is federated learning.
Federated learning, what's that?
This is about training ML models collaboratively, say, across multiple banks or institutions, but without them having to actually pool or share their sensitive raw customer data.
How does that work?
Essentially, the model updates are shared, not the data itself. It could be a real game changer for detecting crime that spans different organizations or borders, all while maintaining data privacy.
That sounds incredibly smart. Getting collective intelligence without the massive data sharing headaches and risks.
It definitely has significant potential, yeah.
Yeah.
The article also notes a big push towards real-time monitoring, moving away from analyzing data after the fact towards processing streaming data.
As it happens.
Yes, to potentially detect and even intervene against threats almost instantly. Much more proactive defense.
Okay. And connecting the dots. Finding hidden links.
That's where graph analytics integration comes in. It's about combining ML with network analysis techniques. Think of it like mapping out relationships. It helps uncover hidden connections within complex criminal networks or funding structures, relationships you might easily miss just looking at individual transactions.
Seeing the bigger picture.
Precisely. And finally, there's a trend towards more comprehensive AI-driven risk engines. The goal here is more end-to-end automation of processes like customer risk assessment, streamlining onboarding, maybe even automating parts of case management.
Wow.
So yeah, these future trends, they really point towards compliance systems becoming increasingly predictive, proactive, and integrated.
Okay, so bringing it all together then. What's the ultimate so what here? Why is machine learning so strategically essential for financial institutions right now?
Well, the source's conclusion is pretty firm on this. ML isn't just, a cool piece of tech anymore. It's rapidly becoming a fundamental strategic capability for effective, modern financial crime compliance.
Can't really do compliance well without it anymore.
It's getting that way. It gives institutions the tools they desperately need to meet the ever-growing demands for accuracy, for agility in responding to new threats, and for accountability back to regulators and stakeholders.
Because like you said, the bad actors aren't waiting around, and neither are the regulators.
Exactly. The article argues that when ML is implemented thoughtfully, governed responsibly, it becomes a critical asset. It helps build compliance programs that aren't just reactive, putting out fires, but are genuinely smarter and more resilient against whatever challenges come next.
That was a really comprehensive dive. We've gone from understanding what ML actually is in this context, how it learns the ropes, to seeing where it's already being applied, the big boost it offers institutions, but also those really tough challenges they have to navigate, like explainability and bias, and then looking at where the tech seems to be headed, all pulled from that FinCrime intelligence source.
Yeah, it really highlights just how vital technology is becoming in what's essentially a constant arms race against financial criminals.
Absolutely. And it leaves us with a thought, doesn't it? Something the source implicitly raises and is definitely worth you pondering. Given this immense power and speed that ML brings to detecting financial crime, especially when you contrast that with the acknowledged hurdles around truly understanding why a model does what it does and that real potential for inheriting data biases. How can institutions best ensure they're leveraging this technology's full potential while also absolutely guaranteeing fairness, transparency, and that crucial layer of human oversight in their day-to-day operations.
Yeah, that's the balancing act, isn't it?
It really is a crucial balance to strike as this technology continues to mature and integrate deeper into the financial system.
Indeed.
And that's our deep dive for today.